Section 2.5 Continuity. If I were to draw a curve starting from A up to B, if I have a continuous function and I start to draw right here, as long as I do not lift my pen from this paper, or I guess from this slide, I have a continuous function from A to B. Let's look at the next slide and see what happens if we don't have a continuous function. Let's start again from A to B, and suppose I started right here. However, from this point, I continued on there. And because of that jump, this function is no longer continuous at this point. Say, call it C. Continuity at the point. Find the points at which the function f in figure 2.35 is continuous from 0 to 4, except at x equal to 1, 2, and 4. We have done this in class, but let me just reiterate what we did. Okay, the points at which f of x, our function f, is continuous are at x equal to 0, x equal to 3, and all the interior points from 0 to 4 excluding 1 and 2. Now, how do we know that the function is continuous in terms of limit? Okay, let's examine at x equal to 0. Notice that 0 is an endpoint. Let's call this a left endpoint. And so we will examine the one-sided limit. We take the limit of f of x approaches 0, coming from the right. Here I have all my x's approaching 0, coming from the right. And where does my y approach? The y values approach 1. And it turns out that f of 0 is also equal to 1. What about at x equal to 3? X equal to 3 is an interior point between 0 and 4. If we check the limit of f of x as x approaches 3 from both sides, because it's an interior point, x approaching 3 from both sides, notice that all the y's are approaching 2. And in fact, what is f of 3? Well, we are lucky that it's also 2. And of course, any interior point between 0 and 4. Here, any interior point between 0 and 4. Between 0 to 4. An interior point could be here, here, 3, okay, somewhere between 2 and 4, between 1 and 2, between 0 and 1. Based on x equal to 0 and at x equal to 3, here we say the limit of f of x as x approaches c will be f of c. So in other words, when we have a continuity at a point x equal to c, the limit exists and it's equal to the function value. On the other hand, if we want to find out where it is not continuous, let's look at these points where it is not continuous and find out why it is not continuous. At x equal to 1, what is the limit of f of x as x approaches 1? Well, we already discussed this in class and we said that the limit does not exist. Although we do have a function value, and here our f of 1 is 1. However, the limit does not exist. At x equal to 2, the limit of f as x approaches 2 is 1. However, what is f of 2? What is f of 2? It's 2. And they are not equal to each other. The limit of the function as x approaches 2 is 1, but f of 2 is 2. At x equal to 4, it does have a one-sided limit, the limit of f of x, as x approaches 4, coming from where? from the left is 1, but just like x equal to 2, it is not equal to f of 4. F of 4 is 1/2. Well, of course, if we are outside the domain, then the function is not continuous anywhere outside, to the left of 0 and to the right of 4. So to define continuity from the previous slide and from the example, what we did is we examined the two endpoints of our domain as well as the interior. And notice that for this function f to have a continuity from the right, the limit exists and it's equal to the function point. At an interior point C, the limit exists as x approaches C because the y values from the left and from the right approaches f of C. And if we have a continuity from the left, the limit as x approaches B coming from the left is equal to f of B, y values approaching f of B. So we have, again, continuity at endpoints and continuity at an interior point.